EMG question of the day. Which of the following is less affected by the choice of concentric versus monopolar EMG needles? A. Amplitude. B. Area of the negative spike. C. Duration. D. Turns. E. Stability. The terms amplitude, area of the negative spike, duration, stability, and turns were mentioned in question of the day number 1. As you recall, in it, we illustrated the motor unit action potential parameters obtained during minimal musculature contraction. These parameters are dictated by biological factors and influenced by technical factors. Technical factors such as sweep speed, sensitivity, EMG machine filters, and needles. In this question, we will address technical factors related to regular needles. Regular needles, the one used in everyday studies, are fundamentally of two types, monopolar and concentric. A monopolar needle, also referred to as an axial needle, which requires a surface reference electrode, consists of a conductive wire covered by an insulator, except at the tip. The tip's bare surface, the recording area, as you would expect, is wider proximally than distally, forming a cone, only exposed to the tissue in its lateral surface. This configuration dictates the real uptake area of the electrode. As we will see in the next few minutes, the contribution of the muscle fibers to different motor unit action potential parameters is dictated by their distance from the recording surface of the electrode. Hence, the amplitude of a discharge is dictated by the muscle fibers action potential traveling within 0.5 millimeter distance from the surface, here expressed as green circles. Thus, the actual uptake area of the monopolar electrode reflects mainly the area of the lateral surface of a cone, as illustrated here. This shape is difficult to idealize for further explanation. Therefore, following convention, we will represent the uptake area as a circle and adhere to the same methodology when discussing other parameters of the motor unit action potential. So amplitude, as we have just mentioned, is dictated by the muscle fibers action potential traveling within 0.5 millimeter from the electrode recording surface. The turns and waveform stability reflects the muscle fibers action potential traveling within 1 millimeter radius from the surface of the electrode. The area of the negative spike reflects the muscle fibers action potential traveling within 2 millimeters radius from the surface of the electrode, and duration of the potential is dictated by the muscle fiber action potential traveling within 2.5 millimeters from the surface of the electrode. These conclusions have been drawn from the study of potential brought about by minimal muscle contraction, but they also apply to spontaneous EMG potentials. So far, we have been talking about axial or monopolar needles, which we hardly use anymore. The concentric needle, which most EMGers currently use, consists of a thin electrode wire, to which we will refer to as the main electrode. This electrode is covered by a thin insulating material, which itself is partially covered by a cannula, as you can see in this illustration. In concentric electrodes, the cannula acts as the reference electrode. Hence, there is no need for surface reference. This arrangement leads to the recording of morphologically different potentials than those recorded by monopolar needles. The reasons for this difference will be briefly mentioned. The slanted electrode tip produces an ellipse recording area, unlike the catch area of the monopolar electrode. The proximity of the main electrode to the cannula, which, as we previously mentioned, serves as a reference, brings stability to the recording, and the extension of the cannula on one side, shielding the active surface of the main electrode from high-frequency waves generated by muscle fibers on the cannula side of the electrode. I will now add on the right side of the frame the figure of the concentric electrode, as you can see here, the symbol of high-frequency filter, and the uptake area of the concentric electrode for the different motor unit action potential parameters. The uptake areas are being represented following the same rules as we use for concentric needles, which I have introduced here in a reduced dimension for comparison. Notice that the uptake area for amplitude in green and uptake area that influence waveform stability and turns in light brown are half the size of the uptake area in the concentric needle than in the monopolar needle. whereas the areas that influence the negative spike area and duration have the same radial expansion in the concentric and monopolar needles. Hence, compare with axial needle recorded potentials. The potentials recorded using concentric needles have different characteristics, which I will enumerate in the next few seconds. The amplitude is about 50% less, waveform stability is about 50% more, turns are about 50% less, the area of the negative spike is about 25% less, and the duration, the least affected parameter, is about 10% less. The reason duration is less affected is because low frequency waves generated by muscle fibers from the side of the cannula are not impeded by the high frequency filtering effect of the cannula. And as you know, it is the low frequency wave that contribute mostly to duration. The reason for the smaller area of negative spike and briefer total duration with concentric needle recording, despite a similar optic area, relates to the short distance between the main electrode surface and the cannula, used as a reference. The proximity of these electrodes cancel synchronous similar amplitude waves, thus their contribution to the area of the negative spike and duration. The short separation of these electrodes also contributes to the lower amplitude of the potential, waveform stability, and the presence of fewer turns. These comparison values correspond to those obtained using monopolar needles with a recording area of 0.17 square millimeters and concentric needles with a recording area of 0.08 square millimeters. The area of the recording surfaces of currently used needles in clinical practice are different from the area of the recording surfaces used for this comparison. So the answer to this question is C. Thank you very much for your attention.